So everything that we say now can and will be used against us.
So let me just take a second to wish everybody a happy new year. It's still allowed to do so at the 3rd of January. So Pascal is feeling better than he did on the 29th of December. So for him, it's a good start as well. So welcome at the first ITGilde Tech Talk of 2023. So please enjoy. And if you have any suggestions for future Tech Talk, please send me an email and I will look for a good speaker to give that Tech Talk. My email address will be in the chat quite shortly. So Pascal, the floor is yours.
Okay, thank you very much, Peter, for the introduction. Okay, ladies and gentlemen, let's get started. So a few things. We're going to have this talk actually about how to deploy Kubernetes with Ansible, and actually do it last year. Actually, a colleague of mine also did a similar talk in that context, and actually we did also a deploy of Kubernetes actually with Ansible. We're going to do it a little bit more advanced now. So actually, what we're going to do is deploy Kubernetes in different ways. I made a playbook, and actually didn't see, by the way, any of my colleagues actually in the visitor list and that kind of stuff. No worries about that one. I use this one also, for example, for a lot of other items that we do. So, for example, installing the Kubernetes clusters during our trainings and that kind of stuff. Using it actually, for example, professionally, actually deploy Kubernetes clusters all over and that kind of stuff. There's still a lot of things actually that can be done with the Ansible playbook, so it's not really finished. Still working on a lot of stuff, but actually it contains a lot of nice technologies, methodologies, and strategies and patterns actually that also in different parts in different Ansible playbooks and that kind of stuff. So quite simple. What we're going to do is I'm going to tell you all about it. I'm going to demo a little bit. I'm not going to do live coding, but definitely going to actually share the secrets of the trade-off, as we call it, with Peter. Actually, the secrets of the guild, because we are ITGilde, so that you can actually learn from that kind of stuff. Later on, for example, I need to make sure, for example, that no one actually burns itself or that things actually explode. We'll also actually open up the GitHub repository, so you actually can clone the code yourself and actually work with that one. So good. First of all, let me tell you a little bit about myself. I'm Pascal van Dam. I'm a trainer since 1999, and the story always goes the same way. I'm actually did my let's say I'm starting with my delivering trainings actually also like Michael with HP and that kind of stuff. In the time that we still had HPX, so I delivered training for HPX 10, EHPX 11, the Itanium systems, performance and tuning, HPX kernel terms, that kind of stuff. Later on, I also actually got into delivering trainings for the Linux stuff and that kind of stuff since 6-7 years actually. Also for Ansible, Kubernetes, that kind of stuff. We create a lot of our own training material and that kind of stuff. So we have our own Kubernetes material about CKA, CKD, and CKS, for example. Lately, together with my two sons, we actually introduced 3 more courses. One is actually about developing in Node.js. Another one that's really popular is actually developing in Golang. And the other one is, the latest one is actually introduction into Rust. And we're currently actually busy with the Linux Foundation actually to create a new course in the Kubernetes spectrum, actually for having a truly developing course or developers course actually in Kubernetes, actually, and not the how to deploy an application, but actually how to write a application so that it actually will nicely be a 12-factor application, for example, in Kubernetes. But again, this will be about Ansible. Okay, I'm actually living in the southern part of the Netherlands. Peter's actually on Amsterdam, so there are quite a few big rivers actually separating us and that kind of stuff. Here the weather is actually quite nice. It's a little bit hot for the time of the year. We have got almost blue skies and that kind of stuff. Darkness will fall actually soon. Next to having a professional life, also have a private life. I'm a single father of 4 sons. The youngest one is actually 7. Then I have one of 17. One of 18 is actually just graduated from gymnasium. He's actually started his studies on the university, computer science. And the eldest one is actually, in this case, 20. And he also actually has a second year in the university and also doing computer science. And both of them actually currently help me in the company creating audio QA actually on the training stuff now. Okay, Without further ado, let's get started. Quite simple. Let's keep this as interactive as possible. And we'll do a lot of improvisation, that kind of stuff. So things will actually go wrong. The more goes wrong, actually, the better it is, because we can solve stuff and that kind of stuff. But if you have any questions, do not worry. Just interrupt me and that kind of stuff. I'll try to answer the question. If I cannot do it directly, for example, I will just actually write it up somewhere and then actually go back to you. Good. Okay. Let me actually give you a little bit of an introduction about how this playbook actually is coming there. In the training, for example, we need to actually deploy a lot of Kubernetes clusters. And of course, for the CKA ones, what we actually do is that the first day people actually need to craft these and actually deploy these clusters themselves completely manually. Most people actually that work really well and that kind of stuff. Sometimes we have 15 clusters with 3 nodes each, for example, running that kind of stuff. For the CKD, we actually do the same thing. But for example, for the CKS, actually we pre-built the clusters. And then, for example, if we have trainings, for example, that are not continuous, for example, not 4 days in a row, but for example, then 2 days and later 2 days, and then actually we let them create the clusters actually for the first 2 days. Then, of course, I need to shut things down actually in the public cloud, because otherwise I will get a Christmas present from Azure and that kind of stuff. And then later on, we have to bring it up again. But mostly, actually, it's better actually to recreate the clusters in a standard way and that kind of stuff. So actually, we created a playbook for that one. Next to that, I'm a big fan of all kinds of things that are not only Intel. So actually, in a lab in an office is a little bit 20 kilometers up to the southern part of this one. We actually have a 19-inch rack filled with 48 Raspberry Pis, 8 gigabytes. And they all also can participate, for example, in Kubernetes clusters and that kind of stuff. Really love actually deploying the one. And also that kind of stuff actually needed to be automated. Next to that, I'm also the architect, actually, for example, for a big company actually in the Netherlands, a contracted one. And for example, therefore, we need to deploy a lot of Kubernetes clusters. We also need to automate things and that kind of stuff. And I had a lot of things actually that I used into my courses. I also use professionally, for example. Okay, so the whole idea was actually we needed something to deploy Kubernetes clusters, but not manually, because actually one time you need to do that. Maybe you even need to do it the way, for example, that Kelsey Hightower describes it, doing Kubernetes the hard way. When the CKA exam was still actually 3 hours, that was actually the best way actually to prepare for that one. But actually, if you've seen 1, seen 2, then actually 3rd, 4th, 5th, 5th, they're actually boring, and actually we can use our time a little bit better. So what we actually did is create and actually first design, and actually I'm going to take you through the whole process. So we need to design actually a playbook that does a few things. First of all, we have, I would like to, the requirement, for example, that I put to place is I would like to deploy, let me see that, here is this. In this case, for example, deploy any Kubernetes version without actually having to parameterize this, for example. Quite simple. This, I would like actually to have my cluster, for example, run with different container engines, container runtime engines, so different series. I would like to have it actually with different CNIs. So, for example, I would like to have it with Cilium, that's currently my darling. We have Calico. Calico is a little bit difficult currently because actually a lot of the images actually are still coming from Docker.io. There's actually Docker Hub, and of course we're using a lot of Docker Hub. So most times I'm actually completely through my quota of the API calls and that kind of stuff. Canal, which we use actually in Azure, and actually I did find a new one. So I have to see what's called, but actually it's the VMware CNI, for example, that will also work. Okay, then actually what I would like to have, it would like to run it, for example, on a host OS that's, for example, Ubuntu, or actually in this case, Red Hat. We have not too much time, so I'm actually going to only demo in this case the Ubuntu one. The Red Hat one has some small issues, but that's really easy actually to pick it up. You can actually see actually how it works, so that's really nice. And for example, we like to install some of the Kubernetes tools, like for example, Helm. Okay. So the first thing, there's another one nice thing I actually would like to do. I would like to have both a single master, and I would like to do a high available control plane. So actually in this case, one so that will also actually configure my load balancer in case of HA. There's a little bit more that actually the whole playbook does, but this is actually a little bit what the requirements that I have. Okay, so the first thing actually that I do is when I need to create playbook for this kind of complex things. I believe we have a lot of people actually on the front door. Let me double check. Where is it? First of all, everyone can see my screen. That's important. So let's go back. There's my Zoom now. Okay, here we go. Oh, 18 people. That's great. Good. Again, if you have any questions, just let me know. Okay, let's go to that. So the first thing actually that what I do is actually make a small design. What would I like to have actually in the playbook? So I'll make it back to this one. So the first thing is actually quite simple. I would like to deploy any Kubernetes version. So in this case, I would use cube-ADM, for example. I would like to run it actually with different series. That means, for example, I need to have different roles, for example, for the actually a role that actually will take care of the container runtime engines. I would like to have different CNIs. So I need to take a role, for example, for the different CNIs. So actually one role that can actually do that one. It should be actually, in this case, independent of the, actually should be capable of being deployed in Ubuntu or Red Hat. So I need to also take some care about that one. Install actually Kubernetes and actually single master HA control plane and that kind of stuff. Okay, the first thing that we normally do when I do this manually is of course quite simple. What we're going to do is I need to configure my nodes. And what I have, of course, in this case in Kubernetes, I do have at least one master node. I will have one or more, one or more worker nodes. This one, green. And of course, you can have more than one. Let's take 2 for this one. And the example that I'm going to show you actually that one has either 3 master nodes, 2 worker nodes, or for example, it will have in this case 1 master node and 5 worker nodes, for example. Okay, so that I need to, and these need to be configured, of course. Some of the parts actually they are similar. So, for example, all of these nodes, they will actually have something like. I need to configure storage. That means in my case, for example, I do not like to have, for example, for Docker actually, or for containers, depending on the container runtime engine that we have. I don't want it to be actually on root volume group. I actually would like to have it at different storage. So all of these virtual machines that are actually created for prior to this one, actually have another playbook actually can do that kind of stuff, but that's a different kind of talk, and I'm going to do that later on. So actually for containers, for example, I would like to have them on different storage. So they have a different disk actually with them, and they need to be installed in this case a container runtime engine. And actually, for now, I have 2 supported. I can only demo 1 in this case. That's actually crio, and the other one that's actually container-d. And of course, if you would like to, you can also put in, for example, Docker. And actually, Docker and container-d, they are not really different. It's actually container-d is on the same website. For example, if you have the Docker, mostly we're using actually the Docker C for that one. Okay, that's actually the container runtime. I need to do some things for actually the firewalling and that kind of stuff. I need to configure, in this case, for example, my IP tables. I need to configure actually for the sys controls, for example, and making enabling forwarding, all the stuff that I normally need to do manually. For each and every node, that's also what I need to do now. So actually, my playbook will actually be having a few modules. One is actually preparing nodes. And we'll see later on, actually, I've made it a little bit more, composed it in smaller parts and that kind of stuff. Then I need to do something that I say, okay, I would like to prepare the master nodes. What I need to do here, and the next thing actually all, of course, modeled around kube-ADM. So what I normally do with kube-ADM is actually, in this case, initialize the master, but it could also, for example, be the leader. And so in this case, if I have multiple masters, I'm actually talking about leader. If I actually have a single master, then the single master is also the leader. Then what I need to do, of course, is configure and initialize the other masters if they are there in case of HA. And I need to, for example, later on then join these masters, the other masters, to the leader. And of course, I need to pick up, of course, the worker nodes. And that's actually when I have, for example, in all the cases, not only the single master, but also the HA control plane. So initialize and configure actually the worker nodes. And then I need to have the worker nodes join the cluster. Okay. Now I need to do a little bit more. So for example, let me actually get this a little bit more readable. So preparing the nodes, preparing the master nodes, initialize the master node and the leader. What I also need to do is actually here configure the CNI, the container network plugin, for example, a Cilium one or a Andrea. That's actually what name I was looking for. That's the VMware one, for example. Do I need to do more stuff? Then I have the masters actually here, so that will work. And join the other ones to the nodes actually by configuring the container network interface here. The container network interface will be automatically propagated actually to the other nodes, both the master nodes as well as actually the worker nodes and that kind of stuff. And most times actually what I also would like to do here is actually on the master nodes, I'm actually going to install, for example, Helm. And in this case for Cilium, for example, I need to install Helm before anything else, because otherwise I cannot install Cilium. Okay, let's get a little bit of a look at it. So if we go, in this case, to my, and again, no worries, I will share a little bit later on also the GitHub repo for this one. What I do have is actually some small single board computers here that actually function also as a kind of a virtual machine server, for example, hypervisor and that kind of stuff. Let me show you a little bit. So if I do this one, these will actually have a few systems on them, virtual machines and that kind of stuff. We're going to do it completely from scratch. So I'm actually going to 441. I'm going to start with that one. And actually what I always do in this case is actually I'm going to lay out the definition. And so what I'm going to do, for example, first, I always start in this case with a inventory. Why do I do that? Because actually it will structurize my work automatically. So in this case, what I'm going to do here is for my system, my first one, I'm going to actually call it the leader. And so this will be part of the Ansible group leader. So if anywhere in my script or in my roles, for example, I'm going to target, in this case, the group leader, I'm going to get this one. If I have multiple masters, I will actually put the two other masters. There might be also more of them, but actually the script currently is limited, hard-coded actually to 2. We can actually fix that one. Actually, it's not really limited in this case by the deployment itself, but actually it's limited by the load balancer configuration, because I didn't put that in, but this one also actually is able to configure the load balancer automatically and that kind of stuff. But let's first do the easy way. So I'm having a single master, that's actually the leader. Then here I put in the other ones. These are actually in this case my workers. I'm having a special group here called nodes that uses the children construct. And that means, for example, in this case, that all the elements, all the members actually of leader, masters, and workers, so in this case, this one and also these 4 they actually will also fall under the group or member of the group nodes. That means, for example, if I use in my playbook, for example, the nodes targeting, then actually go to all the nodes there. So in this case, for example, if I need to configure the container network engine, I'm going to address nodes. If I need to do, for example, things only on the leader, I'm going to target leader. If I need to do, for example, on the masters, then I'm going to use the masters. And if I need to do things only on the workers, I'm going to target the workers. Okay, there's another one that I'm going to be using here. So I'm creating another subgroup, actually a supergroup, and that's actually the name of the cluster itself. Why I do that is actually quite simple. This will give me the opportunity to use another pattern actually in Ansible that's called the so-called group class. That means in this case, any, for example, host that actually belongs to this group, this Kubernetes, and then C441, C is actually cluster, 441 is in this case the cluster name, that will actually have access to exactly the same variables as the other ones. So in this case, leader, master, workers, the load balancer, and the workstation, we're not using the workstation here, they all are able actually to get to the same variables. Okay, how does that look like? Well, quite simple. If you look, for example, here, and I go to group systems and actually have here a file that's actually named after the group, in this case, Kubernetes, and then cluster 441. Then here I can actually confirm, for example, set the variables that I'm going to need for the cluster. And so here, for example, I can set which Kubernetes version, for example, I would do, and all of the members of this supergroup are actually be able to do that, to see that, for example. And so if I need to configure, for example, Kubernetes with writing out the kube-adm init file, for example, I get my information with this one. But also, for example, when I need to get some information, for example, for the load balancer, the load balancer actually knows, for example, which members, for example, are part of this group, and also knows, for example, what the control plane actually is. So normally when I have a single master, for example, I'm actually directly targeting, for example, in this case, the leader. If I have a high available control plane, I should not do that. I should actually have, in this case, a virtual IP address, mostly actually with something called a name actually in my a virtual IP, for example, a server name actually connected to a virtual IP address. I need to do that, by the way, for this cluster in a few moments. And what I need to do then is actually when I go to that IP address, then actually I get fanned out, for example, to the master nodes that belong actually, but I should not target actually the primary leader. I should target actually in this case the virtual IP. That will be actually the IP of the load balancer that will actually fan it out to the master nodes beneath of it. So more stuff actually here. I'll tell you a little bit about skip proxy, for example. We need that for Cilium a little bit later on. Here I'm actually going to install, in this case, the container network interface Cilium with actually this version. This is actually how I would like to have, for example, my storage configured. I get a volume called VG containers. It's actually making use, in this case, of this persistent volume, for example. We got here an LV containers that we're going to create, which has a size of 40. We have a mount point of that one. And let's say, for example, if we'd like to have my kubelet actually also separate in the kind, so that will actually set away 5 gigabytes. That will be mounted, in this case, a file of kubelet. But all the members, in this case, of this Kubernetes C441 group, they will have access to these variables. And it means that all my masters, including the leader, all my worker nodes actually, they will have access to these variables. So if I ask actually, for example, to create the storage for this kind of nodes, they all actually do that in exactly the same way. I do not need to specify that individually for all the ones. And here, for example, you have the container runtime engine, which is of course also on node level. Needs to be installed actually in all the nodes I have, the leader, the masters, and also in this case, the worker nodes and that kind of stuff. And here we actually have the packages that I need to install for crio, and for the other container that I mentioned for containerd, we have that here. And this is actually the Kubernetes package list, which I need to install, of course, also on every node I have. So this is actually the configuration file. I'm using here the group class pattern for that one to get all the information actually that's needed on a node level. All in the same file. So that's one. The other actual way to structureize my work is actually making use of roles. So not one big playbook with a lot of includes, but actually we're going to do in this case, I'm using roles. And common is actually to use in this case a playbook that's called site. And you actually can see how it works here. So here, for example, and no ways I'm going to more in detail a little bit later on. I need to prepare a little bit on one of my routers actually to make sure that I have a virtual IP address a little bit later. Now I don't need that because I'm actually going to do a single master. I'm going to show you also how to automatically install a high available control plane, that kind of stuff. But here, for example, we are preparing the node. So on each and every node, actually what I do, I'm going to actually prepare the storage. I'm going to do the preparations. Actually, in this case, that means we're going to update packages. We're going to set up firewalls and that kind of stuff. Then we're going to install the container runtime engine, and then we're going to make the preparations actually for Kubernetes. That's actually that we always need to do for all the nodes, independently what I'm actually going to do. And actually, if I would stop here, I actually get a container node with only a container runtime engine, but no orchestrator, so no Kubernetes there. So the next thing that we're going to do in this case, we're going to prepare the masters to make sure that they have all the firewalls opened in the right way, for example. And later you can actually see that it will drop the complete firewall because actually Andrea, when I was testing the stuff, was actually having another port, for example, that they need to open. I actually already had, let's say, secured everything down to cilium and that kind of stuff. And just to be able to show them both to you, I just pick up the last rule that's actually dropping the firewall. But no worries, everything is actually here. So what now we're going to do is we have prep the masters. Then we're actually going to do the Kubernetes heavy lifting. So the first thing that we're going to do is prepare the leader. This is actually, and no worries, we're getting to that more in detail. This is actually where the kube ADF init happens. So actually you're going to do here the stuff that needs to be done on the leader. If I have a single control plane, single master, then quite simple, the leader is the master. And actually if I have a high available control plane, for example, I will actually have, in this case, if I have a multiple, sorry, my little one was actually, so if I have actually a multiple control plane, for example, it actually means I have multiple masters and that kind of stuff. But actually, these masters will be actually joined later. I'm only going to pick one, actually, as the leader. That will be the first one. In this case, I'm going to install first Helm on that. Why? Because actually a lot of the CNIs actually, they nowadays can be installed by Helm, or they prefer to be installed by Helm and that kind of stuff. So that should happen. And then on CNI, actually, I'm going to install the configured CNI. Might be different ones, and we can actually select them. Now, the other one is actually we're going to do, if I have, in this case, multiple masters, then I'm going to also here do the installation work, the join work, but also copying, for example, the kube config and that kind of stuff, because actually any master is, of course, also a place for me to get access to the cluster if something goes wrong. What I normally also tell in the classes, so for example, if I have a single control plane, normally what I do is just have there the kube config, for example. If I have multiple control planes, if one of my masters actually, for example, is gone, I would actually be lucky to directly be able to access the other masters and actually do kube control. And I can only do that actually if I configure the kube config on that one. Okay. Then we actually get to the workers. The workers will actually be, in this case, prepared, and they will actually, in this case, be joined to the cluster and that kind of stuff. And the last thing actually is just to make sure that some of the more obscure let's say container network interfaces are working. I'm actually going to disable a file. Normally that's not there. So actually I'm using in production, for example, cilium and that kind of stuff. The whole playbook is actually there to slim everything and trim everything down for cilium and that kind of stuff. But I would also like to demo, in this case, Antria, for example, as a second container network interface. So this is actually one that makes it work, because otherwise you couldn't actually get any network traffic between the pods and services, etc. with Antria. I have to figure out actually how to trim that one down, but it's quite easy to do. And otherwise, it's actually a nice exercise for you to do. Okay, let's go and get a little bit further. So what I'm going to do now is I'm going to show you here. These are the roles. And you see all the items actually that I had in the site.yaml file. They're also here. The first one we're going to actually look at, we actually skip this one, but no worries, we're going to do that a little bit later on. This when we do the high available control plane. But the first thing that we need to do in this case, pick up the site file with it. That's actually, we're going to look in this case at the storage. So storage, that's actually where we are going to configure the storage of the container runtime engine, where it actually puts its images and that kind of stuff. But also in this case, so for example, have some private storage actually with Qubit and that kind of stuff. We have in all these roles, of course, in Ansible, a similar directory structure and that kind of stuff. We have tasks, we have templates, we have files, we have handlers, defaults, vars, and that kind of stuff. This is a very simple one. It only has actually tasks. And this one is not really any rocket science. This is just your normal way actually in Ansible to create, in this case, the volume groups, but also in this case, for example, on the volumes, create the logical volumes. When we've done that, create actually the file systems, and then later on, for example, mount these file systems also. There's one stuff here that's actually a little bit strange. That's actually destroying all PVs. What happens sometimes, for example, when you're on a hypervisor, you actually get, for example, persistent volumes. You actually get, you get actually physical volumes. These have been used, for example, before, so they have some signatures already on them from LVM or from other file systems. And that means, for example, that SVC Create will actually not allow you to use these disks. And actually have this special thing. You only use it once, of course, because if I use it the second time, it would actually destroy complete my cluster, and I can reboot things and that kind of stuff. I'm actually going to zero out, in this case, the first portion of the disk to do that. Might be I need to do that on the fresh system, and we'll see that. And this is actually the storage. And next thing that we have on the list is actually the okay, that one more. Yes. We got actually to the preparation of the nodes, and again, that's here not really much that we do here. So, but actually, this one does have a nice, let's say, trick actually up the sleeve. What I do here, for example, is I'm opening up the ports, and there are a lot of them. And actually, 22 is normal. That's actually one way, for example, do not have a firewall configured. And normally, the Ubuntu ones, for example, they get rolled out by default without any firewall. I don't like that. So most times, I'm actually going to enable a firewall, but I also need to make sure, for example, the port 22 is actually open for that one. There's a reason why I do it this way. So actually having here a list of ports that I would like to open, including ranges, including, for example, the type of connection TCP or UDP that I need to do. Some of them are quite obvious. So for example, these are the gossip ones, for example, that we use for some of the CNIs. 4789, for example, has been used for Kubernetes. 6443, for example, is very important for Kubernetes. I even have a double one in that you see. These are also ones that are being used by Kubernetes. This, for example, is one that's being used by Cilium. That's why we need to open that one. And these two, for example, are needed, for example, for Entria. And the last one is actually opening the ports that we're going to use, for example, for the high ports, the so-called node ports for Kubernetes. Now, I'm putting this in this list because actually that allows me to do a nice thing. Because in one of the goals actually of this playbook was also to create a playbook that is being able to be deploying Kubernetes on Ubuntu, but also, for example, on Red Hat ones like Fedora, like CentOS, like Rocky, like Alma Linux, and that kind of stuff. And actually, they use different kind of firewalls. And I know there's actually convergence. For example, the guys from SUSE are also going to firewall D. I know that Ubuntu is also trying to converge to firewall D, but still they have the UFW, for example. So in order to pick up both of them, I'm actually going to use a little trick of that one. So I've got here the functional stuff that actually tells me which ports to open. Actually, this one is the native format that's been used by Firewall D. It's actually what we started with, for example, and later on we're going to use also Ubuntu. And for example, what I did then is actually creating different task files. So this is my entry part, it's my main part. But what I'm going to do then is, in this case, I'm going to include a task. It actually means that this file gets imported into the playbook in this case. And so actually get imported in the role. And it actually uses the OS family. And in Ansible, the OS family actually, in this case, derives to, for example, Red Hat for the Red Hat family ones, like the Fedoras and that kind of stuff. Like the Alma Linuxes, like the Rocky Linuxes, like CentOS, like Red Hat Enterprise Linux, of course, and that kind of stuff. And they all use Firewall D, and they all use, for example, YIM and DNF and RPM and that kind of stuff. So that actually gives me some structure, actually, and what kind of ending. And for example, the other one is Debian. And Debian, for example, gives me in these cases the DPKG, the APT, that kind of stuff, but also gives me, for example, UFW, for example. So in this case, what happens that this command, when it's being executed, is will either, in this case, resolve to configure firewall Debian, and then actually will get the Debian way of actually in the opening ports in the firewall, or for example, I'll get the firewall section from Red Hat to the firewall. So let's look, for example, at the firewall Red Hat. So actually, this is just an include file. And here you can actually see I don't need to change very much. The only thing actually that I do here is I'm actually picking up the list and I'm actually looping over it. And again, I'm using this call in this case the with_items for the old use of not using loop and that kind of stuff. And this is actually quite nice because actually it was being built first for Red Hat. So this one is actually originally directly being able to use any item that comes from this list and that kind of stuff. And actually, this one could actually be gone because actually I needed that one in the past actually to check if there was an issue with crio-Linux of actually crio-d, but no worries about that one. Okay, if we look, for example, here, then at the Debian one, that's a little bit different. But actually, what I'm doing is first check if the firewall is enabled. If it is enabled, then actually what we're going to do, you can actually see that here. What I do is I'm doing UFDW status. And what I'm going to do is I'm going to pick up the output actually of this one in UFW check. And if, for example, if it is not inactive, then I'm actually going to use this block. And here I'm actually going to check what the outcome is. I like to actually include a lot of diagnostics in my playbooks just to see, for example, what's going on. Yeah, so one way, for example, is to see that is in the past when I actually developed one. I know there's still one issue in that one. I did forget to become, for example, so it was not actually executed with elevated privileges, which means I cannot ask for the status of the firewall, and actually this one would always say the firewall is actually not enabled. But in this case, what I'm going to do then is I'm going to pick up the same list that I'm actually using for the firewall D from Red Hat, but I'm actually going to transform it here. So I'm actually going to do here is we are going to do some transforming here. We're going to split it up, and we're going to replace, for example, the dash for a column and that kind of stuff. And we still do the same thing in this case for the proto. So this is actually the part that's before the prototype. That's actually in this case the port number. I'm actually going to, in this case, not using the dash, we're using the column, for example. This is actually the part after the slash, which is actually in this case the prototype. And we're going to do actually the same thing. And we're going to say in this case state enabled. So in this way, I can use exactly the same list that I use for firewall D, and also get it working actually for UFW, for example. The whole idea is actually to try to do this in a way that I also can really actually extend it to other distribution accounts when they're quite simple. In this case, doing this, I don't know, by the way, what Debian currently uses as a firewall, but all the Ubuntu and all the Ubuntu derivatives will actually work the way. And actually by having the family Red Hat, all of the Red Hat derivatives like Fedora, Rocky, Alma Linux, that kind of stuff, CentOS, really Red Hat Enterprise Linux, they'll all will work also in this way. The other way was actually spell them all out, but that would mean, for example, that I need to have different files, for example, for Red Hat 7, Red Hat 8, Red Hat 9, Rocky 7, Rocky 8, Rocky 9, Alma, and that this is actually much more easy. Well, of course, might lead to issues in that kind of stuff, but they're really easy actually then covered by doing a derivative when it's needed. If there are any questions, just let me know. I know that I might go a little bit fast in that kind of stuff, but we have ample time. But no, please ask. Okay, so that was actually the preparation of the masters. So the next thing that we actually have on our sleeve, check that one. And always I'm going to demo it also. Okay, I'll install this myself. Okay, then the next thing that we're going to do in this case is installing the container runtime engine. So that's in this case another role. And actually here, I'm doing a little bit of the same thing. So you see here, I do have, in this case, a main entry point. That's this one. And what I do here is do the common stuff here. Yeah, so I need to install, for example, that's a description for a lot of the container network interface of container runtime interfaces, container runtime engines. I need to install the VNF filter. I need to make sure, in this case, that it is actually being loaded on boot. What I'm doing here is actually making use of a template, so I actually can change those things if needed. For example, I've created a Jinja2 file. In this case, there's no variables here, so you could also actually do this, for example, with a copy. I can actually show you that one. So this is actually, in this case, the Kubernetes conf.k2. And so you see here the overlay that needs to be always loaded. The VNF filter needs to be loaded. This will then be put actually in the modules one, so that it will automatically get loaded on boot and that kind of stuff. Okay. Then what we're going to do, we need to set up some of the forwarding, system variables and that kind of stuff. And also here, I'm actually have put this into a template. And the reason for that one, it's not really needed, but it makes it easy. For example, if I need to put some variables in, might only, for example, be when this file was altered or by what kind of playbook or role it was altered, that kind of, I can actually then put that in. So, but you can see here, the forwarding, all the stuff that's actually in all the items that we have on the installation of Crio, on the container D, that's actually here. Okay, then the next step actually that we do is we're going to load the system. By the way, of course, this can be done more Ansible natively, because actually also Ansible has a way to work with the syscontrol system and that kind of stuff. This was actually because I couldn't really remember actually how that was done. So quite simple, use this quick one. But again, forgive me, it should actually be done more Ansible native. Important, this is actually always working. This is already, how do you call it, idempotent. So it's not a really big deal here. The next thing that we're going to do is actually install the container runtime engine. So what I do here, I'm actually going to the same way like I did with the firewall. I'm actually going to include in this case a task actually that actually is a derivative in this case of the container runtime name and then the YAML. I'm not there yet because if I do that, I actually get into, for example, install container D, or for example, install Crio, for example. Now, let's say that in my case, we have this one there, and I'm going to give you a quick look at the container D also, no worries. Sorry, that's uninstall. I would like to have install. So here you can see that, but in this case, I still have the two branches. So the first one is actually the distribution specific ways to install it. So for example, if I'm on a Red Hat family system, I need to do the RPM stuff. I need to do the DNF stuff. I need to, in this case, the yum repo stuff and that kind of stuff. If I'm on a Debian or Windows-like one, I need to do the APT stuff and that kind of stuff. That's actually been done in this case here. So here, this one will find out again which OS family I am. Am I a Red Hat one or am I a Ubuntu one? And then that will actually include that one first. That will be actually good first. And then this one is actually the generic part. That's actually where we then do the cleanup, for example, in this case of the network interface directories and that kind of. If we don't do that, and we're going to reinstall, for example, a different network interface, and there was already an old one here, definitely get into some really nasty troubleshooting, that kind of stuff. So that will do. We'll actually, in this case, put on some configuration files for the registries. We're going to enable and start Crio, for example. There's actually here a special one. You can actually see that I actually prioritize this one. Normally, that shouldn't be necessary, but for some reason, actually, the brilliant man of Red Hat and the brilliant man of Ubuntu actually decided, although it's the same Crio, but that systemd servers actually have different names. And sometimes I run into a distribution actually that has, for example, a Crio that actually says in this case it's on Azure Local Bin Crio, but it actually in this case isn't Azure Bin Crio, so I'm also going to change that. This, of course, is only going to apply this when it actually that's the case, when actually it has been wrongly configured and that kind of stuff. Then we're going to restart it again, and there was another bug actually very recently in Crio. That means that on Red Hat system, for example, they have these nice Red Hat registries actually there, but actually the whole Crio, for example, doesn't know anything about the GPT they're using for that one. So in this case, we're actually splitting them up and cleaning that for that one. This one. No worries, that's a little bit above what we're going to do today, but just to show you a little bit how it works. So let me actually go in this case to the Crio packages and then of Debian, so actually you can see what happens. And see, and so Crio, pick that one out. Here we have it. So the first thing that we do is actually in this case using as much as possible Ansible native ways to do this. So I'm actually going to add the key, for example, for the Crio repo, and we get them for the kube-init repo. Most of you might know that one. Then actually we're going to do is I'm going to add the repo to it, the same thing. Then I'm going to install, in this case, the Crio packages from the list. I'm actually using, in this case, the flannel list actually to make sure that it directly will feed one string actually of packages to it, so it will not actually iterate over it. Sometimes you need to do that kind of stuff, because later on I'm going to show you the one when you need to do that. And for example, if I would like to have a special version of a package, for example, then actually I need to do this yeah, let's say in an iterative way. But in this case, I'm just going to feed it the complete list and actually install it. This is actually the place actually that I need to do some parameterization. The whole problem actually that I ran into was that on Ubuntu systems and Debian, for example, they actually called the systemd service crio. The package is also called crio-o, so that's actually quite logical. But for example, on the Red Hat systems, yes, the package is called crio-o, but actually the systemd version, for example, the systemd naming is actually crio without the dash and that kind of stuff. So this is a way actually to make sure that in my generic part, I actually do not need to put a special, for example, branch in that part. So actually using in this case, the variable that I was setting here with set fact. Okay, let's go. And then when we come back in this case to the crio, so the generic part, that's here. We actually did in this case the crio, and actually important as you could see here, this is actually what we're going to use the different names. And to show you actually that it indeed is different with the Red Hat one. So if I do this one, crio packages red hat.yaml. You can see here, I'm using actually in this case, also still the Ansible way, but there might be another way, for example, with your repo and that kind of stuff. But needed to do it quickly. So here I'm actually going to get the URL actually picking up the second one actually because with Red Hat, for example, I need to have both of these repos and that kind of stuff. Then what I'm going to do is clean it up, so make sure that actually that some old stuff like containerd is not there. Then we're going to install the crio package, and you can see here that I'm going to set in this case the variable crio_svc, not the crio with a dash, but crio without a dash. And that way, upstream, I do not have to make any special, let's say, measurements to make sure, for example, that it always works. So all the distribution dependent stuff is now been done here, and now we can actually do in this case the generic stuff for the container runtime engine. To give you a little bit more insight in the other one, so if we do a containerd.yaml, you see actually the same part here. This is the distribution specific part, and here actually we have the part that's actually generic. And if you look at it, for example, pick up containerd, and then this case packages Debian, you can actually see here that we do this then for containerd, and actually this means we do it not really in a Ansible native way. Again, we need to be actually quite quickly, but here's really room for some improvement. I'm actually going to install in this case the GPG keys, and here actually we have some magic actually that will, for the correct Ubuntu distribution, for example, will actually get these containerd ones, and actually then we can install these. Okay. Then let's go to the following. Again, if there are any questions, kindly let me know. So the next thing that we're going to look, we're actually now in this case at Siri. So we're going to check here for prep Kubernetes. That's here. So if I check here, and then we have here the part. Actually, you can also see here, this one is also split up into the distribution family specific stuff. Okay, so actually what we do here is we have here first the distribution specific stuff, right? You can nicely see the pattern in this case. So what we're going to do here, and let's pick up in this case the one for the Debian one, it's also Ubuntu. So in this case, I'm picking up the Kubernetes repos, for example, and going to install them. This is all the Kubernetes and then for Ubuntu and Debian ones. What I'm going to do here, and this is actually nice. Here's some stuff actually where you see me actually looping and iterating over a list. And the reason why I do this is that I would like to have not the latest version. I will always actually would like to have the version that I specify, in this case in my group files. So if you look here, go further here, group files, and no more here. It's C441. Now you can actually see here with above, we see here the version. That's the one I would like to know. That means I would like to have a kubelet of this version. I would like to have kubeadm of that version, and I would like to have kube-control of that version. And I'm actually doing this by making sure that I have, for this skill for Debian, I need to use the equal sign, for example. That means, for example, you have here kubelet, for example, is equal to that version. And then, of course, the -00, that's something that's standard. And actually going to install it here. And here, for example, we're going to do the same thing, but actually then without the version numbers, I'm actually going to hold the packages so that a accidental sudo update, apt update, for example, and apt upgrade will actually not change my versions of kubelet ADM and that kind of stuff, and actually bring version skew in my cluster. We do the same thing, but a little bit different, of course, for the Red Hat one. And also, these things are actually OS family specific. So what you do see me doing here, and again, I'm actually having a much easier way actually to get the Kubernetes repo actually on. We did it this way, then we're going to install them. But in this case, what I'm going to do is here, using the item, and then not an equal sign, but actually a dash with the Kubernetes version. And that will make sure that DNF, for example, in this case, will select for me the version that I intended to have. Okay. Then what we have now is actually the fact that my nodes have been configured. There's now a container runtime engine running on it. The firewall has been configured. I have all the prerequisites there. So actually my network forwarding rules are there. I do have the packages there for the container runtime engine. I do have the packages there actually for Kubernetes and that kind of stuff. So now actually we can go to the next step. That's actually making sure that we prepare the masters. And the next thing directly after that is actually making sure that we initialize the leader. So that will be actually the one that will create the join tokens and that kind of stuff. And then other masters or other worker nodes or both of them can actually be joined. Okay, so what we're going to do now is we're going to look in this case at prep masters. This will be actually executed on the leader and on the master. So that means in this case, on a high available control plane. So when I have a high available Kubernetes cluster, I'm going to do that on all the three of them. If I, for example, only have a leader and no masters, that will only be actually on the first master because there's no other master. So if I check that, we go to prep masters. You can go and you see here we have tasks. And also here, you can see the same pattern. So also here, things are actually there in this case with a firewall, which actually been, in this case, that's actually the most part has been done here. I'm actually going to configure the firewall, for example, and that will be done in this case in a way specific actually for my OS family. Here you see actually here the same trick actually being used. We can actually make sure, for example, that we combine them, for example. And the reason why I didn't combine them now, I actually have a specific role, for example, for the container runtime engine, and a specific role actually in this case that might even double some of the functionality in the Kubernetes one, is actually that I can now use the role actually for installing the container runtime engine, also independent of the Kubernetes. So if I only would like to run, for example, a Docker cluster or a container cluster without an orchestrator, or maybe with a different orchestrator, I can actually use that kind. Okay, now the next time. So what we do here is then we create the master. We're going to look at the leader. So the first role we're going to do is the Kubernetes leader. Okay, Kubernetes leader, that's this one. And what we do have here is all stuff, as you can see, there are actually no OS family roles here, for example, OS family files. This is just completely generic. That's not the farther actually I go into the playbook, the more generic stuff works, the more easy actually it is also to write and to maintain. And actually what I'm going to do here is I'm going to configure, in this case, most of us actually have learned to install Kubernetes using a kube-adm init, and then actually put a -- port subnet consider that kind of stuff. And that's actually what they do. There's another way actually by configuring it using a so-called YAML file. And the YAML file, for example, has some really nice options actually to do. Sometimes we cannot do that actually without it. So for example, cilium is one of the network interfaces that we use. Actually has a way, for example, to go kube proxyless. We've got a nice workshop that I'm planning actually to do also for Peter a little bit later on. I'm using that now for some other companies and that kind of stuff. And we're going to show you, for example, what you can do with CNI as cilium, because it's really, really powerful for security and that kind of stuff. Therefore, for example, I need to install my Kubernetes cluster in a little bit of a different way. And that means, for example, I also need to put some stuff actually in a file here. So let me go and see that. So if we go, in this case, to the templates directory, you can find here the cube ADM in it. And actually you see here a piece of Jinja. If you, for example, have been to the talk of my colleague Gabor a week or two ago, he was actually talking about Python and Jinja 2. This is actually Jinja 2. What I'm actually doing here is that if I have in my group file, so my group files file, actually in this case, the Kubernetes and then skip kube proxy, for example, if that is actually true, then quite simple, what we're going to do is I'm going to include also this piece of YAML, and that is in this case, for example, to skip, in this case, kube proxy. Why would I do that? Well, quite simple. Cilium has a way to completely skip kube proxy, which actually makes my cluster leaner and meaner, and also makes it a lot more faster because Cilium actually based on eBPF, the extended Berkeley packet filter, is actually doing stuff much more faster than kube proxy is, and actually have all stuff actually then in one CNI, and I really like that kind of stuff, and also makes it more controllable, more observable. Okay, normally we do not have that, so skip proxy will actually be false, so actually this will not be in it, and actually then my kube init file, kube ADM init YAML file will actually start by this one. This is actually the piece of YAML that we use to configure the cluster. That's why the kind is cluster configuration. We get the networking here, so this is actually the service subnet, and I can also configure that one in the group files file. The pod subnet, I can actually put up my own domain name. The nice thing about this one is, for example, if I'm going to install Cilium, I need to specify in this case also the DNS domain. And actually by having all that stuff actually there in the group files file, all the other roles actually that are having access to these nodes, they can also get to this configuration information. And so in this case, then the Helm, for example, command that we're going to use to install Cilium, we're going to pick that out a little bit later on, can actually use this DNS domain name, so it actually will work and that kind of stuff. You put in the cluster name, this is the version, and this is actually the control plane endpoint. And again, normally it's not that important if I have a single master, but if I have a multi-master, for example, this should be actually the IP address on the load balancer and that kind of stuff. So, but this will write it out, and then later on, actually the tasks in the main file, for example, they will actually do them in kube ADM init. So you can see that here. This cannot be made in this case, more, let's say Ansible native. This is just what we need to do with shell. I'm going to feed it the kube ADM init file. And in the case I'm going to use multiple masters, or actually later on I'm going to upgrade the cluster to multiple masters, I need to do this upload source thing. And also what I'm going to do is actually makes it easy for me to check, for example, what's going on. I'm actually going to in this case, the output to a different file and that stuff. Not only for myself, by the way, because later on, when I'm actually going to install, for example, multiple masters, I also need to get a certificate. I can get my join token, for example, that's not a problem. But the certificate, for example, that's really more difficult actually to get that. So actually what I'm going to do is later on, when I have a multiple master, I'm actually going to pick this and filter this out from this file. So it's not only for me, it's actually also later on functional in the thing. Then I'm going to use the kube proxy directory. I'm going to create that one. And I'm actually going to make sure that it's been owned in this case by my owner, because actually I'm using in this case the become yes. Then I'm going to do in this case is I'm going to copy the configuration file. This is what we normally do manually, the 3 lines. That actually just copy, make directory, copy, and then change owner, that kind of stuff. That's actually been done in this case automatically for me, in this case on the leaders. So good. Yes. And then we go to the next one. So the next step actually is, let's go to this one. You can see here, I'm actually going to install Helm. And actually that's not really a very difficult one. Straks wel. Straks, nee, gaat niet. Sorry, my little one is there. So what actually do here is we install Helm and actually going to download it directly. Of course, if we are in an air-gapped environment, I should download it from one of my internal systems and that kind of. This is actually just to show you what's needed. Okay, and we have Helm. If we have Helm, then quite simple, we can do the next thing. Because actually, if I install the CNI as soon as possible, and actually I can already install, in this case, container network interface, of course, when the first master of my cluster is there. Yeah, because quite simple. That will allow me to install all the API resources that are needed for the CNI. And when I'm actually going to add another node, be it a master node, be it actually a worker node, the stuff is actually getting automatically propagated to the other nodes in the account. So, but I have the choice actually to do it directly, or for example, do it after that I've already joined all the nodes. I find it more clean actually to do it directly, because then you can also really see them that the cluster is actually propagating the CNI to the other nodes in the account. So, okay, this is a little bit of a more complex one. So what you can see here, and also this one is actually in this case making use of the entry point main. And actually here what we do, we have the configuration variable kubernetes.cni, and that's actually the task that we're going to execute, or the task file. So for example, if I go to Cilium, that's one I'm going to demo, you actually see here, first what it does is actually adding the repo of Cilium, in this case, to my system. Again, if I'm air-gapped, I need to make sure, for example, that I get it from somewhere else. Then actually what I'm going to do here, and this looks really, really impressive and quite simple. Cilium is not an easy one to do, but it's definitely very, very, very powerful. Debugging it is not really nice, but actually debugging stuff that you are running on it, that's actually quite nice. So what we do have here is that we say, okay, we're going to install Cilium, in this case with Helm, and we're going to install this version. You can see all of these are actually getting from the group files file. In this case, a kube system. I'm going to make sure that this one actually brings its own English controller. Kube proxy replacement is strict, which actually means in this case that we can do stuff with replacing kube proxy. That's the reason why we did the skip one, for example. You see here Kubernetes service host. That means actually be in this case the host name, for example, the service port. We're setting here the relay and the Hubble. It's actually a way to, for example, see what kind of traffic using the user interface is actually going to my cluster, that kind of stuff. We make sure that the user interface being enabled. And you have more stuff here, for example. Here, the cluster name. Normally I need to find out actually what it was. By actually using this group fast file, I have all the information ready for me. So the ones that are used by creating the cluster, also the ones, for example, that I can now use in configuring, for example, the CNI Cilium for that one. Again, not all the CNIs actually have this really extensive way of configuring. Definitely can tell you if you do not do that, it will not work. So also the other one, for example, is I do have another cluster domain, for example. I could have another cluster domain than the default one. If I do not specify it, for example, quite simple things like the Hubble relay will not work, the Hubble observability will not work. So that's actually here. So there was some more stuff actually, because with Cilium, there actually also comes stuff there that actually allows me, for example, to see the status of Cilium. That will allow me, for example, to see the status of Hubble and that kind of stuff, to see what kind of traffic is flowing to my cluster and that kind of. Again, if you're interested in that one, definitely subscribe to the workshop that will be coming about Cilium and that kind of stuff. Also running this stuff for earlier, not only on, in this case, ARM60 or AMD 64, but also on ARM64. The problem is that here what we have is that some people are calling ARM64 ARM64. Other ones actually call it ARC64, for example, so a different thing. And the same we actually have for AMD, for example. Yeah, it's x86-64, but sometimes also called AMD64. What actually we're doing here is make sure that we use one convention in this case. In this case, the convention has been used by the ladies and gentlemen of Cilium. So I'm actually going to do is getting the different kind of binaries actually there. I'm going to copy them. I'm going to impact them and that kind of stuff. Going to download, for example, the Hubble command line interface. I'm going to copy it, etc. Not going too much into detail about this one because actually, but to show you, for example, a more easy one. Let's pick up the Antria one, for example. This is one that's actually been also really recent, been used by the VMware guys, for example. We do a lot of courses, for example, we deliver in this case for it's not called Canal, this is one's called Antria. And actually, this one's quite simple. The only thing actually that it does is apply in this case, and we use the version number in this case from the group was one, and then actually it will apply this one. It's not all the CNIs actually have a very complex and extensive way to configure this one, so but it's all possible. Okay, what we have done is actually quite simple. I do have all my nodes that have been prepared for receiving containers, have container runtime. They have actually the Kubernetes tools like cube-ADM, kube-control, and kubelet ready, but only the leader, the first master, that has been initialized. Okay, so the next thing actually that we need to do, and it depends on actually what my cluster is looking like. I'll actually show you that. So you can see, for example, here, we did pair the leader. See, now it's the last thing. If I have other masters, so if this one is actually empty, then it will not do this kind of stuff. But otherwise, what it will do in this case is then also to the Kubernetes masters. And what we actually do here, of course, is a little bit like what we do on the leader, only of course there we do not the kube-ADM in it. There we also do actually a join. And there's one actually special thing here. That's actually okay. And took a little bit of a while to actually find things out is, for example, the control plane cert that we get. You cannot, for example, recreate that using a kube control, a create join token, for example. Now, when I have a worker node, for example, I would like to join to my cluster and I forgot the token or the token got expired, the only thing that I need to do is a kube control token, create ping join command, and I can happily actually do that one. For a master, I also need to actually hand over, in this case, the master control plane cert. And that's not really easy actually to find a one. So actually what we did, is by the kube-ADM init that I did on the leader, I actually wrote that one to a file. And the file was actually called kube-ADM init without. I did tell you, I did use this for myself, because quite simple. I can actually then observe what's going on, if something goes wrong in that case. And the other part is actually quite simple. It also contains, in this case, the join command for that one. So actually, in this case, the control plane part. So what I'm going to do here is I'm going to, again, this is not a native Kubernetes, or not native Ansible in this case, but there might be faster and better ways to actually do that. But again, this is a read action, so it's actually idempotent in itself, so it's not really a big issue in this one. But this can also be done actually more nicely. But what I'm going to do is I'm actually going to check in this case for the dash control plane, and actually give me the command and all the items actually that. And actually what I'm going to do, I need to delegate this. And that's also a nice trick actually. This means that this task will actually be executed not on all the nodes that actually belong to master, but actually in this case specifically only on, in this case, the node that goes by the name of leader. And in this case, because also leader is actually a list of nodes, when I'm actually going to a list of host names, in this case, I need to have the first one. So that's the reason why there is 0. If I do not do that, I get a list. I need actually a scalar. So this is a way to get the scalar action. Okay, then it's quite simple. I'm going to get the normal token actually from the leader. It's not a problem. I'm also going to do that here with the same construct. I'm actually not, for example, remembering it, or in this case, I could actually also get this one, of course, from this file. It's also there. But actually, I would like to see if I could work, how that would work out. For example, it's actually the same command that's been used in this case for adding worker nodes and that kind of stuff. It's actually the same tokens are being used. The only thing that's different in this case is this master control plane cert. So actually I'm going to pick up the control, the token here. So I'm actually registering here. So the output's being registered in this case in this variable. And then what I'm going to do is I'm going to have the master nodes join the leader. And I'm doing that in this case by picking up the token standard out and actually, and then putting the part of the cert behind it. And then again, I'm going to make sure that I put everything actually there in a file. So later on, I can see over to other masters, for example, what's being. But actually what happens here, this is a kube-ADM join, but then in this case, not for the worker nodes, specifically in this case for the other masters actually there. And again, what I always teach in the CKA courses, I say, guys, quite simple. If you have a high available control plane, make sure that if you need to go to the cluster and you need to go to a master node and one of your master nodes is down, that the other master nodes actually are there to really receive you in a warm way, so that you do not need to copy actually the kube directory. That kind of actually is already there. I log onto the cluster. I can do kube control, and the node, for example, that are still there will actually help me not do that kind of stuff. This will be done on the 2 other master nodes also. So I actually have then 3 master nodes. They're actually completely equal in functionality. Okay, so that's actually what we do here. So the status is now that I do have a Kubernetes clusters with 3 masters. So we have managers, but we have no one to do the work. So the next thing that we need to do, of course, is to have the worker nodes there. So let's go back to the site YAML, and we see that here. So what happens here is that we're going to do, in this case, the workers, and that's actually all the magic has already been done. So this is not really so we go here to the workers. Okay, up. So into the tasks, and again, got the main file here. And the only thing actually that happens here is what I'm going to do is I'm going to say, hey, do a cube-adm token create from join command. And I'm also going to delegate that one to the leader. The first one, that's actually the one that actually has it, but actually other master nodes could also do that, but just let's keep it clean. And then quite simple. There's no trick actually to do. I can do that, for example, the previous master, but I'm also picking, in this case, all the worker nodes and that kind of stuff. So this will actually work. Unless, of course, if I would do it really nicely, then maybe I could, for example, even directly target, for example, the system using the virtual IP address, for example, of the load balance and that kind of stuff. But again, a lot of stuff actually that we can improve in this one. So we actually get the worker join token, and then actually what we do is we visit each of the worker nodes that we have. It could be 3, could be 5, could be 8, could be 10, could be 300, and we all going to join then in this case using cube-adm join, and then with the join command and that kind of stuff, and we actually get these to do. And again, Kubernetes does all the hard work and will actually propagate the CNI, all the stuff actually there to the other ones. So okay. Let's see if we can get this working. Again, are there any questions? Good. Let's see if we can get this working. So I'm going to check a little bit. I'm going to do first the easy part. It's actually going to create a cluster with a single master. So we're not using a load balancer in this case. So what will actually mean is that the 441 NO01, that will in this case be the master, and also the leader, of course. And I got 4, in this case, worker nodes. Okay, let me double check in this case for what I'm going to do. And again, my appearance of my cluster, the properties, that I will find actually in the group file. So I say here, let me do 124.6. I say this is the pod subnet, and I can some of the cilium of some of the CNIs, for example, ignore this one. But this is actually what I have by default. I know, for example, cilium, for example, pick its own one. That's not a big problem. Here's the cluster name. That's good. The domain name is in this case cluster local. We keep it that way. This is the control plane. It's actually the default one. What I actually do here is that in this case, the single master is the leader, and I'm actually going to say that its host name on port 6443, that will be the endpoint to talk to the API to. The next part I'm going to do, when actually this is successful, I'm going to also use the same playbook actually, but then to configure, for example, for a high available control plane. Then actually we're going to have here is a control plane that actually has, for example, in this case, about 4 formal master. There will be a virtual IP address that will be put on the load balancer, for example, and then there will be actually that endpoint. And the virtual IP address will actually fan out to one of the 3 available masters. And again, I need to prepare a little bit for that one because I didn't choose that cluster yet, so everything could happen, but that's great. Okay, I'm going to do and live dangerously, so I'm actually going to, in this case, show you all the tools I have. So what I'm going to do in this case, I'm going to say I would like to install, in this case, Cilium as my CNI. I'm using, in this case, the latest and greatest stable one, this 112.5. This should be the same. Might be that I run into a small issue due to the fact that, again, on the system where I created these virtual machines, actually, that it will find out there was actually an old persistent volume, actually an old physical volume, for example, that still has some signatures. That means I need to enable the zeroing of that device one time, but no worries, I can also see that. Use crio, and then actually this can actually be kept exactly the same. Okay, here goes nothing. So what I'm going to do here is Ansible playbook, give it the c441.inf, and then I'm going to say, let's do site to YAML, and let's see what happens. Okay, the first thing what we see here is now actually that I've never logged onto the system. So this is not being set up. You're not being faked. This is the true work. What I did now is actually, in this case, I'm running a export Ansible host key checking as false, because I do not want to, for example, say yes, 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 and that kind of stuff. I actually say, okay, I deployed these systems myself. Definitely, there's no man in the middle attack. Otherwise, I'm at myself. But in production, normally do not do that. But in this case, it will actually work. So what it does now is gathering the facts. Let's see how far it comes. Okay, it's creating the volume group. Okay, we have lucky because it didn't see actually any signatures. So what it's doing now, it's actually in this case creating all the storage actually there on all the 5 nodes. You can see that has done that. What it does now is configuring the firewall. Now it's configuring in this case the network filter one. Now it's in this case installing the container runtime engine crio on all 5 nodes. And again, 1 master, 4 worker nodes. You can actually see that one. Actually see if this is also working. Takes a little time. So let's see how the repo is being added. That's good. Yellow is good. Green is fine. And red is issue.
Em vez de você vir me buscar, você descansa e eu vou para casa. Aí eu não te acordo quando eu chegar. Você dormir pouquinho, porque você deve estar morto de cansado.
Now it's installing the crio packages. That takes a while. Let's see if that works fine. And again, in this case, the target hosts are Ubuntu. You can see that because actually it's picking up in this case the Debian family of YAML files, so the Debian family of tasks. Okay. This is the part that I do not expect too much problems, but it takes a while. Okay, what I can do already, can I do that? Yes, I can. To pick up this one. Okay, it's already not going to. This is the first one. So you can see them dropping in now. Okay, what's also nice. I need to do that a little later. When we have a high available control plane, I can also show you, for example, this how the load balance is being configured, in this case using HA proxy for that one. So now you can see that the crio is actually being enabled and started. Okay, it's running. Now it installs the Kubernetes part. So now the Kubernetes repos are being configured. And again, we're doing in this in the Debian family way of working. And you can also see here that the nodes actually where it does this on. So that looks good. Now it's going to install the packages.
Pascal, we have a couple of questions over in the chat, the last 2.
Okay, great. I didn't see that yet. No worries. Let me check. And thank you for reminding me for that one.
Para cada canal, você pode decidir quem vai trabalhar em 100 vagas, quem vai trabalhar em 50. Você pode decidir quem vai ter acesso ao FX Loop ou não, quando você ligar, acionar lá no boot switch. Que canal vai ter acesso, em que canal
you can get them from me, Yellow. Take a little bit. I need to clean a little bit up to make sure that no one blows up his system and it's going to blame me. But I'm going to, in this case, send them to Peter, and Peter will send them to you. How idempotent is cilium does it allow for network types configured pod links to be able to use TCP/dump for packet captures? Jeff, what cilium does is, for example, you can see all the packets actually, in this case, traveling from pods to other namespaces, from pods to external. You can see that, for example, on layer 3, layer 4, and really nice, you can also see that on layer 7, for example. To give you a little bit of a hero story, we all know about Log4j, yeah? That's actually the library that, for example, some of the Java guys actually used, and someone actually that didn't really think about it actually made a call home in that one. And we got a lot of issues actually because a lot of malware actually was taking care of that one. With Cilium, we're able actually, because there we can also actually do network policies on layer 7. We were able actually to figure out, for example, when such a layer 7 call was done, so we could stop it. We could also, for example, trace it back to the pod that was infected and that kind of stuff. So that way, for example, we got a lot of customers actually we were able to help that way. Much easier, for example, than those that didn't run in containers. So we actually also use this one to convince other customers actually to migrate to containers as soon as possible, because it would make things more controllable and more secure if watched carefully. And so, but you can also do that with TCP up, but actually Cilium has its own tooling for this kind of stuff. And you can even have, for example, there are 2 versions of Cilium. You got the normal, the consumer edition, the community edition, and the enterprise edition. And the enterprise edition, for example, you get even more nice graphs actually to see which packets are flowing, when they're getting rejected, why they're getting rejected, and that kind of stuff. Hugo, how important this will be? 2 ways. In this case, very idempotent. That means that, for example, in this case, I can actually get each time exactly the same cluster, for example. In this case, when I rerun the script, it actually will rebuild a new cluster. So that's also idempotent because I always get the same result back. But what you could do, for example, is if I find out that a cluster is already running, and for example, I need to add another node and that kind of stuff, I can actually, for example, create functionality in this case. So it's idempotent, but in this case for recreating new clusters and that kind of stuff. If you actually would like it not to harm your current cluster, for example, you need to actually build in, for example, to see if nodes are up and running, if they're healthy, or maybe, for example, put in a configuration option that says, okay, redo from start, for example. That would actually do what it does now. And otherwise, for example, it would change, for example, compare the result if you like. For example, you have 4 worker nodes and you say there should be 6, then it will actually go automatically the 2 other ones. It does not do that yet, but that's not a problem to actually build it in. I did check if I could build it in just before our talk, but other work actually prevented me from doing that. Okay, you can see now here that it's actually going to initialize now the leader. And if we're a little bit lucky, let me see that this is actually 441. So I'm going to do this 440 and 1. Pick up this one.
Quem que vem? Seu pai, sua mãe, Silas, todo mundo?
Control.
Não, mas você está falando por causa de buscar? Não, buscar não tem problema, não. Só tem que arrumar coisa para lugar para ele dormir aqui, né?
Now it's installing the Cilium container network interface. You can also see actually that's good. You're welcome, Hugo.
Tem que arrumar, olhar esse negócio de colchão, né, para ele e tal, né? Mas isso que eu tô te falando, pra gente olhar isso antes, né? Mas de buscar lá não tem problema nenhum.
That sounded weak. But I only speak
Tá bom.
so.
Tá bom. Não, tá bom, gatinho de leite.
Okay, now let's check. You see here, actually, the cluster is now still in not ready state. Let's see if it actually is able to recover from that one. What's nice actually to see, for example, now is to take a look in the engine room. So if you look now, for example, at the Cube system. Okay, what we see now is a few things. First of all, we see the operator from Cilium is running. You can now see the daemon sets for the Cilium CNI. They're automatically now being propagated. And so my Kubernetes playbook is ready. So actually it has done its job. Of course, what we actually did is declaring a desired state. Kindly give me a working Kubernetes cluster. And actually Kubernetes is now doing the hard work. Let me see if that works well. And so we actually see some nice stuff. You see here the operator nicely running. We see here the init containers of Cilium coming up. You can actually see a core DNS in this case recovering, because actually core DNS needs actually the network interface, because otherwise it cannot land on the masters and that kind of stuff. So that's running now. So that actually means that core DNS is happy. Now we're waiting in this case for the Cilium ones actually to get up and running. Let's see that. I'm always a little bit worried when the init containers, in this case, they even 4 init containers. So that's quite a beefy, yeah, let's say pod. Okay, now actually it says, okay, it's 02. Let's wait. Okay, these two actually now, for example, do crash loop back off. It's not a big issue. We do see that much more. Actually, now it's going. You see the init containers pod initializing. That means now that actually the application containers get running. Okay, that's good. It's always looking at a at a match or something like it. A football match. Yes. Now let's wait for the other application container to get up and running. See that. Sometimes Cilium, by the way, has some issues, but let's see if I do now, for example, kube control get nodes. Now, mostly we have all the 5 nodes ready. That looks great. I'm not really happy again about the 1-2s. Oh, that's good. They're coming. Only one now. You can now see that the Hubble relay is actually going down. Fortunately, we do not have time to demo that one. That's also a different workout. But let me actually show you that we actually have a working, we should have a working, say kube control, working Kubernetes cluster, do a full deployment. Which one? Do me a no code. How would you like into that? Please do me quiet.io, and then for me, and then in this case, no code 392. Do me in this case, got 4 worker nodes. Do me 4 replicas, and I know something's running on port without. This is actually a application that my eldest son created. We're using that a lot, for example, in the courseware, because actually it's one of the tricks I learned from Michael, for example, putting gamification in your training and that kind of stuff. So that's one of the good parts of the ITGilde. Actually, learn a lot from each other. Okay, let's see. Get pods. Okay, one is running. Keep control. Get pods minus O white. And you can see here that here Cilium, for example, it doesn't listen actually to the pod IP addresses, the subnet, for example, that I created. And that's not a big issue. Let's see if I can actually get some traffic on it. So if I do this, yes, you can see the application is actually running on this one. We can also then do an expose to create a service, deploy. What we'd like to deploy, in this case, or what we like to open up, that's no code. Do a kube control, get service, do a curl of 10.96.122.190, then on 3000, and that will nicely also give me a round robin, the different pods that I actually have. So this will give me a running single master 4 worker node cluster. I didn't do anything with it, and actually that works quite well. And again, improvements, completely right. You go out. What you could do, for example, is now it's actually destructive. I'm going to show you that. Of course, I need to do that. But I didn't need to do that. But actually, for example, I could decommission, for example, in this case, node 2 and node 3, and actually convert them, for example, to master nodes. But the playbook does not take that into account. It's now actually quite simple. It initializes all stuff. We'll go a lot faster than the first time, but let's do that. That's the last thing that I'm going to demo, and then we have some more time for questions and that kind of stuff. Good. What I'm going to do now is a few things. First of all, I'm going to use this copy, and then I'm going to scan to my router. Okay, then I go to the long stuff, then I go to the HP server, and I need to make sure that I pick one. So if I do Yep, that's not used. That's great. So I'm going to do this, and I'm going to do here. Even een Niels-vraag. Okay, then I'm going to add this one. Good. Now let's see if I do have, let's see, 441 master. Okay, that looks good. So I do now have, in this case, a virtual IP address, this one. Okay, okay. Now, let's do some more stuff. And again, could be that this will fail, could be that this will be successful like the other one. Let me see. Okay, what I'm going to do now is going to make some small changes. So the first thing that I'm going to do is I'm going to put up these there. If there are masters, they cannot be workers. The next thing that I need to do is see if I get the load balancer. That's this one. That's in this case, I believe 440. Let me double check that one. 440 LD01. That doesn't look good. And let's take this one. 440. .inf should be that. Okay. Yes, this is it. And let's see. This will be my load balancer. Good. Double check everything. Yes, that looks good. Again, I'm not doing anything with the workstations. That's it. But normally, for example, what I do for customers that we have, I'm also going to, for example, deploy the kube configs actually on their worker nodes, so they actually can use the clusters, for example, with their own users and that kind of stuff, with diminished right and that kind of stuff, and being able to switch from one cluster to another one by switching the kube control contact, for example, and also, for example, giving them access to K9 and that kind of, all the kind of stuff is actually possible. Okay, more stuff. Let's go to this one now. So I need to see 441. So what I need to change now is the control plane. That's actually already there. So 443, that works. I'm using the same cilium, not going to change that one. I can actually reuse this, so that's also good. Not going to change the pins, that will be great. Do I need to do more? No, I don't believe so. There's one more thing that I need to do. That's actually, in this case, via inside YAML. You can see here the load balancer. That needs to be done now. Okay. So I got the role of load balancer. And again, you can see in this case that my load balancer has access to the IP addresses of course, itself, of the masters and the leader. And this is one that we didn't talk about yet. And actually, here is also some magic there. That actually took quite some figuring out actually how to get that done. So, for example, what we do have here is the load balancer configuration. And the load balancer in this case is nothing more than just an HA proxy. It's running on the Ubuntu system. This part, by the way, is not multi-architecture. It's actually only running in this case on Ubuntu. It has a little bit actually still there. For example, it's at Cebu, for example. You can see that I tried to get it running on a Red Hat family, for example, but this is actually not running in Ubuntu and that kind of stuff. You see here, we actually put up the firewall. We're doing actually the same thing that you did see in the other one, for example, setting up the firewall. Here is actually what we're going to put in this case, the virtual IP address for the master, in this case, on the IP stack. So actually what I'm going to do is in this case, on the Ethernet adapter of the load balancer, I'm going to put the actual IP address there. Two of them on there, so hopefully it will also work for the other one. Then what I'm going to do is, I'm going to configure, in this case, hproxy.config. And I'm actually going to do that with a boilerplate template. And then actually for each of the clusters I have, I'm actually going to create a front end. You can actually see that here. You can also see here, again, using this group fast construction, I'm actually making use of that collected sets of variables in the account. So the same cluster name I'm going to use here. In this case, the kube master IP, for example, I'm also going to use that here. The cluster name, I'm going to use that here again, and I actually use that in this case for only the Ansible host when it's actually targeted in the load balancer. Then we need to actually set up the backends. And that means in this case, this was quite a trick to actually find out how to do that, because actually this changed over the Ansible versions, for example. What actually the whole idea is that I do have a list here of Kubernetes server entries, and that list actually contains all the endpoints actually of the backend. So in this case, these contains all the IP addresses and all the names and that kind of stuff of the master nodes that I have. And actually, this list needs to be dynamically actually added to, and the whole way actually to add, for example, items to a list where actually the items in the list actually are variables. Because actually what you can see here, I have here, this is okay, to the list Kubernetes service entries. I'm going to add another list item. You can see that here with the square brackets, for example. This is a literal. This is actually something that, in this case, Ansible needs to convert, because this will sound okay. Use the Ansible hostname. That's actually the system we're going to target. So in this case, that will be one of the masters. And actually go that over all the masters, for example. Here you can see that with item, that's actually in this case the Ansible. Actually, here we only pick up the leader, by the way. And here we pick up the same thing, but then actually with a master. So actually get a list, in this case, for example, of one leader. And then actually, we actually configure this, for example, to 2 masters. But actually the code will actually give you, if you would like to have 7 masters, that's also possible. That's not a big problem. What we're going to do then is actually, when I do not, for example, have multiple masters, but I still would use like to have a load balancer and to later, for example, add high available masters. I can also do that, for example, but in this case, we're only going to do that to a maximum of 3. That's actually the limit in this one. Then what I'm going to do in this case, pick up all the backup entries in the list. And actually, here you can see also I'm limited to 3. But what you could do, for example, is actually in Jinja, use actually a for construction, for example, and write out, for example, every entry that you can find in this one. But this was actually there to get it working in that kind of stuff. So still a lot of things can be innovated and can be improved upon. Then we're going to restart HAProxy, and actually the rest of the stuff is just like we actually already showed you. So let me see, again, this can go horribly wrong, and this can go just fine like it did with the first one. So I'm going to do this. And again, what you did see, the only thing that I changed to go actually from a high available, from a single control plane to a high available control plane is, I needed to make sure that I rearrange, in this case, the distribution of my nodes. So in this case, 3 masters to worker nodes. I needed to, in this case, uncomment the load balancer part, and I needed to change, in this case, the endpoint, because that should not be, in this case, a single node, because actually would have a single point of success, a single point of so failure then in that case. And actually I need to use that for the load balancer one. So let's see if it works. Again, we'll go a little faster because quite simple. The cluster is warm. All the container images for Kubernetes, for example, are already there. The only thing that changes actually, it will now, for example, and again, destroy the old cluster. You can see that and do that on the fly. All the stuff will go a little bit faster. You can see that here it is. The firewalls, the storage was not a big issue. So you can see now this is the load balancer that's been done. What's actually quite nice, actually that's not a big problem. Oh, that might be a problem, by the way. Okay, let me double check one thing, because this will might, and then we'll start HAProxy. I need to look into this one. Kubernetes C2 4 and I'll be 01. Okay. Let's see what I did with my HAProxy configuration. Actually it doesn't look too bad. It's here what's bad. I've wasted actually in my old configuration. Okay, let's do something manually. You can see here the front end. This is the issue, but for some reason it removed my old one. So actually, you can see that this is trying to do the old one, and that's actually where it goes wrong. That's actually, this one should also be there, but actually this one it actually killed off. No. Okay, I need to look into that. I didn't test it actually by doing things end to end, but then this will happen. I can actually pick this one out. So let me see if I can get my HA proxy. So system control, status HA proxy. Okay, yep, I can go with that. Let me do this. That's actually looks nice. I can't this one, I guess. No, pick up this one. Oh, maybe I already have it here. Let me double check. No, it isn't. No, let's do this. Good. Okay, that's good. By the way, you can see that now one endpoint is running because actually, I didn't destroy the old cluster yet. That has actually one endpoint there. Okay, let's go back to this one. Can I get here? Then I get back to this one. Now I'm going to humble a little bit. So I'm going to already set up, in this case, the load balancer. So I'm going to point that out. And let's now see. So another improvement would be, of course, that if the load balancer cannot be configured, for example, I should actually not go with the other roles. Okay. Here we have. Now it's going to do that. Good. You see this goes much faster because actually all the things have been done. And to show you the idempotence, yes, this part, for example, is idempotent. Okay. A few moments, we'll see this one go from green to yellow and red because it will kill it. Okay. Now you can see in a few moments that it will go from green to yellow and red. Also for the first one. Yes, there it's yellow. In a few moments, we'll see node 1 getting yellow and green again, then node 2, then node 3. So you can see here, this is the firewall still. You can now see, by the way, that it opens up more ports because the worker nodes are now being converted into master nodes. That means extra ports are being added. Okay, now we'll see that the leader will be initialized. See, it will be yellow, now it's green, and the wished situation is now that the other two will also get green. First, it will do is actually install the network interface again. Okay, now it's actually picking up the other masters and join them. So now will 2 and 3 will actually go, and they will go in parallel. So which one will win? Takes a, oh, okay, that's correct, because actually 2 and 3 will master over worker nodes. So they need to pull in actually all the container images. So it takes a little bit longer. I was getting a little bit worried, but it's explainable. It's plausible. Good. Okay, today, please. Must be a busy day on my cluster. Yes, there we have. All green. Okay, so that means that this guy will also show that the nodes will be there in a few moments. This will actually, in this case, yep, there it is. Yep, you can also see that here. You can see that in this case, so it will be control plane. This will be a control plane also in a few moments. They're not ready because the container network plugin has not yet propagated. Yeah, now this one is also control plane. Actually, we can check that one. So keep control, get pods minus and keep system. So you can see here now here that the operator is starting stuff and actually pulls in the cilium on all the 3D master nodes. So now it's actually doing the same thing for the worker nodes. Now there's the worker nodes there. So now we actually need to wait for the cluster to settle. We can do that actually this way. And then I'm going to demo that also this should work. And then we're going to conclude the workshop. If there are any questions, of course. Okay. Okay, one more worker node ready. One to go. Yep, let's see that also in the engine room things are quiet. Almost. I need to have one cilium actually. That still needs one container active. And then actually good to go. That means now we're good to go. Okay, the proof of the pudding is in the eating. So what I'm going to do is to create my deployment again. That's a flat. And if I do keep control, get pods minus or wide, you can see that here. And if we're lucky, here we have it. So one high available cluster without me doing too much work. Okay. Yeah, this was all I would like to tell you in that kind of stuff. If you have any questions, just ask. And what I'm going to do is I'm going to clean up the repo a little bit, and then I'm going to ask Peter to share the repo URL with you guys. Is that okay? Okay, any questions? Okay, if there are no questions, then I would like to thank you for your attention. And I would like to invite you for another call, another workshop, for example, that we will give. Thank you very much and have a pleasant evening. Okay, right there. Why are the non-masters not getting any role? That's actually by default. What actually happens is that you can actually have them another role, and in some of the Kubernetes distributions like OpenShift, for example, there they actually have a different role. For example, you can actually put another copy or replica, for example, from etcd on that one. But by default in Kubernetes and also in the newer OpenShift, we actually don't do that. And actually, when it doesn't have a role, it's actually working out. And when it has a role, for example, it has, for example, the role of a controller and or, for example, a etcd, that kind of stuff. So. Yep, definitely, you can do that. Let me see. By the way, this one also works on Raspberry Pi, so I didn't have time actually to show you that, but I can show you, for example, that this one. If you do that, keep control, get here, it's minus and white. This is, for example, a cluster that was been built using a Raspberry Pi. So you can also see that one. Okay, let me show you the HA proxy. Good. Not this one. I go back to this one. ZO and then LB. Yes. HA proxy. HA proxy.config. And in this case, the magic happens here. And so here, I do have the front end. And this is actually what we're listening to. And this is actually the IP address that I actually put on the network adapter extra. And then actually what it does say in this case, we proxy stop we're not using in this case. Then actually the default backend is in this case the Kubernetes C441 service. And it's actually down here having the backend one. This is actually a cosmetic one that tells me, for example, the service. Some people, for example, call them master 1, master 2, master 3. I actually would like to have the node names there so I can directly see, for example, which node I'm having it. This is actually the IP address of the node. And of course, 6443 is actually just the API endpoint. And in this case, this means that we have a simple check actually to see if it's alive. Oh, that one. Yes, no worries. Can do that. So that's this one. Is that what you mean? Sorry. Good guys. Okay. Again, many thanks. What I'm going to do is I'm going to make dinner for my kids, and I hope to see you a little bit later on. Okay. Bye-bye, and have a pleasant night. And of course, the best wishes for the new year. Thank you very much.